Yeah, can you all hear me okay? Should I get started? So first of all, I'm actually presenting work by my co-founder and colleague Ines Montani, who apologises that she couldn't make it here today, but I hope that I can do a decent job at presenting her slides. And we've worked on these things together, even though it is primarily that she's been the lead author of this software and the system that's behind this. Okay, so what this talk is all about is basically the need for annotations, and that's the sort of primary need we've found in machine learning projects. So to give you, basically a little bit of motivation for this and why we think that actually talking about annotation and the data process is probably the more important thing to be talking about in machine learning at the moment, rather than specifics of how to fit different models or, how to get an extra 1% accuracy on using this type of solver as opposed to another type of solver and this type of architecture. I think in general, actually, the data and modeling problems are probably the most common reason that projects will fail. So rather than focusing on something which, maybe get you an extra 1% or another 2%, focusing on questions around the data, I think, is actually going to send more projects that otherwise might have struggled over to something that would have been successful. So why is that? Well, so in general machine learning, we can think of this as sort of programming by example. And all that I mean by this is that as opposed to traditional type of software development where you specify a behavior in code and then you send it off to a compiler and you get back a program, in machine learning you specify some behavior by giving it some data that you want to basically, especially in supervised learning, you give it data with labels and then you want to have the machine replicate those labels. So the annotations are how we specify the output we're looking for, as opposed to in a normal program where you specify that output with code. And so obviously creating these annotations is how we create new behaviors. Even if we have an unsupervised method where we don't have those explicit labels, we still want those explicit labels to evaluate, because there's kind of this meta-learning step of you evolving the unsupervised method, and so the evaluation is going to be how you basically climb that hill. Okay, so hopefully having seen why we need this annotation and why it's so central to the projects, the next question is, well, okay, but why do we need this process to be particularly efficient? Could it be that the annotation is something that anybody can do and it can be done fairly cheaply? So why is this a section that we need to optimize particularly? Why isn't it just something that it's a detail that we have to take care of, just like hosting a server or something? Well, I think that annotation is actually quite different, and I do think that it's a common source of problems. So, in particular, annotation is something where you need to iterate. You can't expect to have the task defined correctly. Even for something where you think that that you want a pretty simple, say, entity recognition annotation, and that this is something that many people have done before, there are always no end of boundary cases that you'll meet in your data, and those boundary cases will basically be defining the policy that your model is trying to learn. And if the policy that your model is trying to learn is not consistently annotated and the boundary cases are not clear, then that will severely affect the accuracy of your thing. So trying to decide what's in and out and how do these things work is quite central to being successful in these types of projects. And it's very, very difficult to do this ahead of time before you can actually start interacting with the data. So actually taking an iterative approach is super important. And because we need that iteration, the implication is the good annotation teams are small. We can't just say, all right, we need 100 hours of annotation, so let's get 100 people and give them 1 hour of work each, because then you only get one iteration step. And that means that the data that you get from that first iteration step will largely be not so useful. So rather than having a team of 100 people and having them do 1 hour each, it makes much more sense to have a team of like 5 to 10 people. And this means that you want the annotation tool to be as efficient as possible so that then you can decrease the latency that would otherwise introduce. And so finally, a lot of the things which we want to do in machine learning are not low-value click work at all. They're things which where you really need specialist knowledge. So we've been talking a lot to teams who, say, are in engineering and they want to work on safety reports, or people in sciences and they want to work on scientific articles or this type of thing. And so, if we step back and think of the promise of something like natural language processing, we think of it as, all right, language is the human information system. We want to automate a lot of the high-value knowledge work, augment that high-value knowledge work, then the knowledge that is required for that is quite, specialist. And asking a, highly paid engineer to use an inefficient annotation tool means that the project tends to not go so well. The work is less efficient, and you get pushback from the people whose skills you're trying to access. Okay, and then finally, all right, so it's not just, if it needs to be efficient, then, why specifically semi-automatic? Like, why do we think that this is a particularly key aspect of the solution to this type of problem? Well, the thing is that if you're performing boring, unstructured, and multi-step tasks, your reliability and accuracy of those tasks is going to be quite low. We can't take it for granted that just because a human did some annotation, that annotation is complete and correct. And the tooling that you give people in the processes and support that around that have a huge impact in what sort of accuracy you actually get from this. It's not the case that just, the human annotation is necessarily better than the machine annotation. They tend to make different mistakes. So in particular, we'd say humans are good at context, ambiguity, and precision, while the computers tend to be better at things involving consistency, memory, and recall. And so if you ask a human to basically make the same decision like 1,000 times in a row, they're not going to get it right 1,000 times in a row. Whereas if it's, sort of simple, then a computer can augment that and make sure that they're sort of more accurate. So it's good guide rails for people to be working with as well. Okay, so if all of this seems kind of clear and, you're like, all right, well, that's kind of, maybe obvious even. Why do we still have this problem so often? Why isn't this process better in most teams that we've talked to? And I think that the thing is that most people have a pretty bad experience of doing the annotation, and it tends to be a step of the process that people step away from or shy away from and want to do less of. And so, why is that? Well, I think one of the key tools that people actually go to if they have nothing else, then they'll go to something like an Excel spreadsheet, especially if the annotation should be done by, basically these professional type people. Excel is, kind of like the first line of defense data tool that people use. But it's pretty limited for annotation, and it's pretty hard to automate things within it. And then even once you get that, it's hard to get the data back in, as good a structured format as you want. So then people often go to an external tool like Mechanical Turk. But the problem is that this still makes it difficult to iterate because there are so many other sources of problem that you can have if you take this sort of process. So if you send out your data to Mechanical Turk and you get bad results, then you're not really finding things out quickly. And so that means that you're, also much, you're moving much more slowly. So you've got too many extra explanations introduced. So then, all right, if we're not doing that, then what could we do instead? Well, a lot of teams say, well, this annotation process is kind of the weak point in our process, so what should we do instead? Well, you can do unsupervised learning, but then you really lack a way to guide the model towards what you want. And also, even if you want to take this and apply it, you tend to have to do at least some annotation to map the unsupervised categories that you have back to something that you're interested in. So even if you take a more and more unsupervised approach, you still need to have this sort of solution for annotation. So we think that there's still a need for this stuff. So what we say from this is that the thing of labeled data isn't the problem, even if people are finding that that they're struggling with this. It's actually the data collection process. And so we've been interested in finding better ways to do that and better ways to engage with that, and also try to solve it. So I guess a key point of what that solution looks like, or a key aspect of what we think can make it better, is to make this the questions in the interface like simpler and more granular. So instead of presenting people with a whole document with and you read it once and produce all of the annotations that you want in that document, which is the way that a lot of annotation projects are structured, we're going to break things down more and more and ask individual pieces of information, sort of one at a time. And even though this gives the annotator less context around those individual decisions, there are many, many advantages that make it worthwhile. So I'll try to convince you of this. So the first one is that if you break things down into these binary questions, or questions with sort of fewer choices between them, you get a much better annotation rate because you spend much less time interacting with the tool, and you're basically just streaming this information from you into the computer. So instead of having many clicks to make an annotation that basically just like navigate the tool, there's really only this like one click that's giving that bit of information to the computer. So the information density of your actions with the tool are much higher. Another one is that the inter-annotated reliability is much, much easier to measure. So if you go back and look over somebody's annotation decisions, because they're only deciding one thing at a time, you can very easily give them guidance around that decision or very quickly check their work. So you can give people sort of this guideline set to work on, and if they're making different decisions from the ones which you specify, they can only differ in one way. Whereas if you have something like a fully structured entity annotation, they might get the boundaries slightly wrong or decide this category versus that category. There's so many more dimensions of things that they can do differently, and the feedback that you can give them comes so much further away from the decisions that they made. And so that makes it much more difficult for the annotators to learn the things. And so, even though this binary interface seems limiting, it's actually much more flexible as well, because any of these tasks which you're trying to learn obviously can be reduced to some series of binary decisions. I mean, that's just how information works, right? So the question is how to do this basically efficiently enough that we can do this. And there's a bunch of sub-problems to solve that we've been engaging with, and I'll show you how that works basically. So first of all, here's what this looks like in the tool that we've built, Prodigy, which is the annotation tool that basically implements these insights that we have. You can look into it at this URL. First of all, for something like entity annotation, here you can see that the candidate phrase has been highlighted with labeling, and then you just say yes or no to that. All right, fair enough, fairly clear. Then, for object detection, which is also a structured information task, because you've got multiple pieces of information that make up the complete annotation as well, you just, you can say yes or no. And then you can extend this out to basically clicking one from a sequence of categories as well, if you know that, all right, I just want to give them these 4 things to choose between. But already here you can see that you have to make one click here and then one click here. And so this is like necessarily slower. As opposed to in this case, you've got the label attached to it and you say yes or no to it as well. All right. So how do we make this happen? How do we get sort of reasonable enough suggestions from the machine that we can be saying yes or no to that can guide us towards the thing? And also, if we're getting these suggestions, how do we make sure that we're covered so that the machine doesn't get stuck and, only know what it knows and we can't introduce enough extra information? So I guess a key insight here is that from this type of process, you're able to tell the computer the rules and annotate the exceptions. So if it's the case that, 90% of the time some category applies to some label, rather than annotating all of the cases where it does, you can get that suggestion sort of by default, and you can say no to the ones where it doesn't apply. Or you can even have the machine filter out the ones where it's most confident. So in order to bootstrap this, we can also build those rules semi-automatically using something like word vectors or some other process of lexicon construction. And, we want to avoid annotating what the model already knows. We do a simple uncertainty sampling, but, other approaches to this can work as well. But actually, the uncertainty sampling is a pretty good sort of default for this type of active learning process. So the first step, as I said, is, we can just sort of start building a terminology list. So basically, you start, give it a few seed terms, and you can imagine we've got a sort of pre-constructed word vector representation, and you can start saying yes or no to some of these terms. So we say, all right, maybe we want terms with sort of governed locations and things, and so we say, all right, we start with a few examples. Something where we, maybe it applies, but we don't necessarily want it in a terminology list, we can skip. The point here isn't to be, sort of have entire correctness, or completeness. It's to basically start bootstrapping. So we start annotating the terminology lists so that we can start building out a seed list of rules. Okay, and then from the terminology list, we can transform this into a little expression grammar, which is just sort of like a token regex that is going to search over the tokens. And so in this case, we might look for the lowercase form of this one word. But we could also look for multiple words. So we could have the next, a previous word as an adjective or something like this. Or we could have a multiple adjectives before a word or phrase or something. And we can tell it which label to suggest for this. And so that's enough that we can, basically start getting suggestions from this rule list. And so once we're getting those suggestions, then we can start training a statistical model on top of that. And so we have this sort of one loop where you start training a statistical model that's, you start out from learning from these patterns, and then before long it starts, at the start it only knows what's in your patterns, but then as you proceed through, it's able to sort of start generalizing, because the model starts making suggestions, and at first they're wrong, but then you can basically make those corrections. So here we can see another example of something like, you applying a text classification label to something like an information extraction thing. So here we might have a pattern which we've looked for, which to highlight a particular type of event or a particular type of message that we're looking for in text. And if we wanted to model that as a text classification problem, then we might start off by having some sort of phrase recognition thing and applying a sentence label over that. And then we might find, all right, if we can do this accurately enough, then this is a simple way to perform the information extraction. On the other hand, we might find that this approach doesn't work well enough, and we might find, okay, instead we need to actually pay more attention to a syntactic structure or semantics. But if you can annotate quickly, then you can very quickly try out these different approaches and basically start making these different decisions and different evaluations. So here we see a label that we might apply to this, and so we might have something like a multi-expression pattern. So something like an entity type of person. If we've recognized the text and tokenized it, we might have James Gorman as one token as a person, and then some word with the lemma receive, and some other token with the entity type money. So how am I doing for time, by the way? I haven't been tracking this properly. Okay, great, thank you. So yeah, you can see how even something where the pattern is quite abstract, it can recognize these candidate phrases, and that can be enough that you can be saying yes or no to this and start building out an annotation set to basically start the bootstrapping process. Okay. So I guess the message that we have here is that we don't want to just iterate on the model. It's quite well established in machine learning that we can't. We've only got kind of quite weak guidance from our intuitions about what type of models will work, and it's a very experimental process. And when we get out to the level of hyperparameter search, it's like even more experimental. We don't have a very good. We've only got a pretty vague sense of what sort of combination of learning rate and momentum we might need. You basically just expect to do some sort of search over this. But what I'm saying is that the sort of much higher leverage things to iterate on are actually the questions which apply even before you collect the annotated data. And so if you can iterate on these questions about how to model the problems, instead of just questions about how to solve the problem once it's modeled, then you're able to, you've basically got a much better chance of making big differences in accuracy rather than, already having a problem which you're going to be stuck on. So the analogy that this doesn't seem to, there we go. Okay, so the analogy that we have here that I sort of mentioned before is that, it's quite obvious in regular programming that we have the source code, and that's the thing that we, iteratively develop. And then the compiler is normally fairly fixed, and then we get our runtime program. It seems fairly, not very useful to iterate on the language level or on the compiler level. That's a much lower leverage part to be changing. Instead, it's going to be much quicker and efficient to iterate on the source code. And so if we think of machine learning as programming by example, and source code as being the part that specifies the behavior of the model, then it also seems similarly obvious that the part that we should iterate on is the training data, and the policies that we put into the training data and the way that we model the problems in the training data. So if it's the case that some information extraction task can be solved with, I keep seeming to fast forwarding through this now. So if we can, if it's true that some text classification problem can be modeled, some information extraction problem can be modeled as text classification, well, that's a pretty efficient type of annotation to produce. And this also tends to be something which models are more accurate at. And our life is going to be harder, and the project is going to be much more complicated if you actually have to annotate structured data and use a structured model as well. Whereas if you can say, all right, I'll just annotate the entities and then I'll apply a binary label where it of like, has compensation message. And then if I have a rule frame that says, okay, I'll take, the first person that occurs in that, and then, the first money entity, and say that, all right, that's their compensation. If I can get away with that, then that's going to be a great way to solve that task. And so I want to know, you want to, basically know whether that's going to work. And so annotating some text at the, sentence level is a good way to basically start deciding that. And so if we take this process of, basically assuming that a big part of the task is modeling rather than, this fitting the data, then you're going to have, basically more success at these things and basically have a much better chance of quickly solving these problems. Okay, so what I'm saying here is that, if you can really get mastery of this annotation process and feel like it's just sort of another step of the pipeline rather than this bit that's sort of annoying where you have to, say, talk to your manager and get the data team on board and, you have an idea and you then want to design a spec and throw it over the wall to them and they'll like work on it for a while and throw you back some data. That's a very slow way to work. It's slow when you're writing those specifications for code, and it's slow when you're writing those specifications for data. Whereas if you can have a process where you can, very quickly try out the ideas that you're interested in, then you'll have a much better chance of having success at these things. And so, ultimately, fewer of these projects will fail. And I think that in data science, it has this problem type where a lot of projects fail, and then some are wildly successful and deliver huge business value. And so what we want to do is have this more iterative approach so that we can, more quickly hone in on those successes and have more of those home runs. And I think that the data is a key part of that, of making that happen. And then finally, you can build entirely custom solutions. So you're not dependent on external vendors and basically assuming that, Watson will solve all your problems or something, and then you're not and then if that's not working, or if the process change, or if you want to do something that's slightly different, you don't have to go back to the supplier. You're kind of fully in control of the whole process, and you're able to reapply that data or change the system at a later date. So, thank you. So the question is, can we add more metadata? The answer is definitely yes. Like, sort of, first of all, both in principle, because I don't want to just talk about this particular software package. I'm hoping that, regardless of whether you happen to use our software, I think that the same principles of, how to think about annotation projects and why to do it in a very iterative way apply. But specifically within Prodigy, yes, you can. So you can customize the view however you like, and the tool happens to take a data format that's basically just a stream of JSON-L or Python dictionaries, and so you can put anything you like in there. There's also an HTML view so that you can basically customize the display of what's shown. So the question is, as you're making these updates, do you learn in an online way where you kind of progressively make the update as new information comes in, or do you have to stop and do a batch learning process where you make several passes over the data? I would say that you can definitely learn in an online way, and what we do is, basically make these online steps for each batch and then sort of periodically revisit previous data. But there's definitely an advantage in, basically training to convergence on a data set which you can shuffle and make several passes over. So what we normally advise people to do is train for a while in, this online setting, and then basically when you want to actually output a model that you'll use in an offline process, run a batch training. And we think that that's, it's as well as we can try to do it designing online algorithms, it's still a difficult constraint, and there's a real advantage in being able to train to convergence on a fixed data set. So the question is whether the specific tool Prodigy is useful for larger teams, or whether it's mostly useful for single developers. So we did design the tool with very much the single developer case in mind, because we think that that's the biggest gap in the process. Like, there was definitely something that there wasn't something else like it that existed. But there's definitely teams using it with more people, and we're building in an extension that makes that much easier. So it's much easier, basically a sort of extra logic layer that makes it easier to route data to different people and replicate annotations between them, and basically have more onboarding flow and stuff. So at the moment, in order to use it in that sort of larger scale setting, there's a bit of extra plumbing that you have to do, and we're working to take care of that for people. So I think it is useful in both contexts, but especially for the single developer case at the moment, because there's kind of not a good alternative. So the question is whether, still the data scientist should be annotating when, you know what you need and you need thousands of annotations. And so quite simply, no. By the time that you've done the early iterations, it's kind of like any other iterative process. You start off with kind of a small step size, and you basically want to be doing a couple of hours, do another couple of hours and see where you are. But then by the time where basically you're pretty confident, you've been working on this for a couple of weeks, then certainly you should be having more people. And that's the point where, there is this extra bit of logic about routing out the task to multiple people that, we have teams who've done this themselves, and it's not terribly arduous work, but it is something that we're, basically going to be taking care of for people in the extension product that we're building. Right. So the question is, do we have a process where if you say, no, that's incorrect, you can actually just make the correct annotation? And yes, there's an interface mode where you can basically click and drag or click, unselect some suggestion. But you can still actually get to the same result without doing that. If you've got enough text as input and you can basically just let the model stream through it, the model uses beam search to suggest a range of annotations. And so you'll still actually find that it does start suggesting the things which are correct. So, but certainly if you want to make evaluation data or something, then it's you really obviously want one text with the complete and correct annotations, and there it's useful to just be able to select them. And so yes, we have that mode.
Great, thanks.